Well, good afternoon, good morning, or good evening, depending upon where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a really interesting topic on tap today for the webinar, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded. So if you miss any or all of the event, you'll be able to access it on demand. We'll be sending out a link after the event in an email that you'll be able to click on to get to the webinar. And we are taking questions from the audience. So at any time during the presentation today, if you have a question, please just use your GoToWebinar control panel and submit your question. And then we'll take probably about 10-15 minutes or so near the end of the presentation and go through those questions. And finally, we do have a few polling questions. So we are hoping that you guys will be kind enough to give us your answers as we push out each of the 3 polls during today's event. Okay, with that, we'll go ahead and get started with today's webinar, the Microservices Manifesto, how to get more out of the development lifecycle. Our speaker today is Chase O'Quine, who is Technical Evangelist at AppDynamics. Hi, Chase, how are you?
I'm doing excellent. How are you?
I'm great, great. Thanks for being here. And I know you have a lot to talk about, so I'm going to go ahead and turn it over to you right now.
Awesome. Thank you for having me. I appreciate it. So today we're going to be talking about the Microservice Manifesto and basically how you can get more out of microservices in your enterprise. Before we get too far into this, I got to go over the typical legal stuff. The stuff in here is proprietary to AppDynamics, blah, 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 et cetera, et cetera. Read that. There you go. Excellent. So that being said, I'm Chase O'Quine. This is the Microservice Manifesto. The way that I like to go about this is kind of the way that we think about SDLC within an organization. We're going to start from a business case scenario. We're going to start, and then we're going to move over into the actual engineering aspects, and then the long-term care and feeding of microservices as they develop within your organization. So the first thing I'd like to ask before we get started is a quick poll. Where is your company at with microservices? So kind of how much adoption do you have for that right now?
Yeah, so I'm sorry. I didn't mean to trample all over you there, Chase. The poll is should be on your screen right now, and you can select one of the following: researching, currently doing small POC, some systems using microservices, or all microservices all the time. So go ahead and make your submission, make your selection, and then when we have just a few more people voting, then we'll go ahead and share the results. But while we're waiting, I do want to remind the audience that at any time during the presentation, if you have a question for Chase, you can use your control panel and submit the questions. You don't have to wait until he's done with his presentation. So, okay, with that, I'm going to go ahead and close the poll and share the results. Looks like the majority of folks are still in the researching phase of microservices. Chase, does that kind of jive with what you've been hearing in the industry in general?
It does. A lot of people haven't quite fully adopted microservices yet, but that's great. That means that you're going to be a good audience and that this is going to really resonate with you, especially those of you researching and kind of still in the early phase of trying to go down that path.
Nice. Okay, I'll go ahead and hide these results and let you get to your presentation.
Awesome. And so so I've got a couple of goals in mind for what I want you guys to get out of the day. First, terminology and taxonomy. I think the way that we speak in business and especially in our industry is incredibly important. And there's a lot of words that get used within our community as a whole, but especially when it comes to microservices. And I just want to make sure that we're all on the same level as far as what we mean whenever we say certain things. I also want to hopefully help you get out why you might bring microservices into your organization. But just as important as why you might, we also want to go over why you might not want to bring microservices into your organization, because as good as it is for solving some problems, it's not necessarily good for solving all problems all the time. From doing all of this, my goal is that you'll be able to ideate faster, so you'll be able to get your ideas out the window and into production at a much quicker rate. You'll be able to deploy more safely. So if currently you're having issues migrating development code into your production environments, we want to be able to get that out there a lot more safety without downtime and some of the challenges that typically come with large enterprise scale deployments. And then lastly, we want to help you scale to the demands of your business, not just from a technical standpoint. Of course, we do want you to scale from a technical standpoint, but we also want you to be able to scale with the way that you manage and handle these projects whenever it comes to you and your business. So what is a microservice? That's a great question. Simply put, it is a self-contained domain-specific service. That's it. That's all it is. It doesn't have to be any more complex than that. And in fact, I would encourage most people, everyone in fact, to try not to overcomplicate it, because we tend to do that pretty heavily as engineers. So let's start with a little taxonomy. What is cloud? What do I mean whenever I say cloud and within this conversation? So cloud is not a place. Cloud is not Azure or AWS or a similar vendor. Cloud is a set of patterns, practices, and principles that let us scale our applications to meet the demands of business. And there's a few things that are kind of a requirement for that. One, things need to be on demand. So whenever we're thinking about the resources that we need as engineers and from an IT organization standpoint, we need to be able to get what we need when we need it very fast. Secondly, we tend to want our individual components distributed. Now, how distributed is going to be very dependent on your individual use case and what you need. That might mean just a few different services on a single VM. It might mean multiple VMs within a physical box. It might mean multiple physical boxes on a rack. It might mean multiple racks in a data center or multiple data centers across the globe. That is going to differ entirely depending on your need as a business. And then lastly, we want to scale horizontally. And the reason that we want to do that is whenever it comes to our cost for performance, that cost does not scale linearly. So if you are traditionally, whenever we've thought about building out larger systems, we do it by buying bigger boxes, right? And the problem with that is that if we start buying bigger and bigger boxes, up to a certain point, we stop getting gains that are equivalent to the amount of money extra that we're spending to get that next larger level of box. And so our performance curve tends to be logarithmic, but our cost curve tends to be exponential as far as how much hardware we're throwing at it whenever we're just buying bigger boxes. And that's not very good. That's not being diligent with our money as organizations. And also it makes it very difficult to figure out just how much additional gains we're going to get and how we're going to be able to meet the demands of future acquisitions, new customers, new data flows, et cetera, because we can't really accurately predict that. Whereas whenever we scale out horizontally, if we know that we can get X amount of IOPS per each individual unit, and we can scale out those units as a kind of finite scoped set of compute and resource, that enables us to, with smaller individual boxes, scale out at a very linear pace from a cost and performance perspective. So if we need to double our performance, it's going to double our cost as opposed to go up by a factor of 10 or more. So 3 other points on what is cloud. Whenever we're thinking about building in a cloud kind of way, we want to make sure that we're building to fail. Because of the on-demand and distributed nature of building in this kind of an environment, we want to ensure that we want to just expect that things will fail, right? And whenever we build out, we want to build with that in mind. So just assume that things will fail and build accordingly. We also want to keep things loosely coupled from an infrastructure standpoint, because we don't necessarily know where everything is all the time. And so if we're tightly coupling, if we have to really care about where things are at in our infrastructure, it becomes very difficult to move things around and very difficult for us to manage our systems. So the classic example is treat your VMs like cattle, not like a pet. If you start naming your VMs, you're going to get very attached to it, and it is going to fail, and then you're not going to have a reliable way of moving your resources around whenever you need to. So thinking in a cloud fashion kind of keeps all of that agnostic. And then my last point is we want to try and favor as many existing solutions as possible whenever it comes to how we build out infrastructure and how we build out our core services that enable us as a business to be successful. And the reason for that is whatever your business is, that is what your business is, right? So whether that is being an e-commerce solution, whether that is maybe you're building out software as a service, maybe you are a shipping company, maybe you are, whatever it is that you do as an organization, that's what your business is. So unless your business is specifically to sell infrastructure software, don't build out infrastructure software to meet the demands of your business. There's already somebody else out there who's already building it out. It's going to cost you less money to have them focus on it, and it will keep you focused on what you're doing and allow you to accelerate to the demands of your business. So last thing I want to touch on a terminology standpoint is what is a service? So this is the most overloaded term in our industry because you can have a service as a service, hosted in a service, sold as a service for a service. And that is an English sentence that makes no sense, yet makes some sense. And so I don't like that. So whenever I use this word service within this context and within this discussion, what I mean is basically just something that does work, something that a piece of software that is sitting there doing work. Now that work may be serving up web pages, and that work may be serving up API requests, and maybe chugging through a queue. Doesn't really matter what it does individually. It's just sitting in the background doing work. So we're all kind of familiar with the most common architecture. It's the classic three-tiered approach to building out software. You have a presentation layer, a business logic layer, and a database layer. Unfortunately, in most organizations, this is not really how this manifests. How this tends to turn into is a UI and business logic layer, and then behind that, a data and business logic layer in the form of large stored procedures that contain a lot of business knowledge and a lot of business insights, and then UI that does a lot of combining and mashing of different data sources all up in the UI. And so this tends to lead to monoliths. Whenever we have monoliths in our system, they start out with the best of intentions. We go in because we want to be fast and we want to try and get as much product out the door as possible. So we're just throwing stuff out there, throwing stuff out there, throwing stuff out there. And then before we know it, we've got all of a sudden got this huge, unmanageable, difficult to deploy beast that just continues to cause us problems. So to fix that, we try and put red tape around it. We try to put processes around that monolith to hopefully make it easier. But then as we onboard more employees and more people are working within the same environment, it just gets more and more difficult over time. Typically, when we think about a monolithic application, there are two monoliths. There's the monolithic service and the monolithic database that goes along with it. And we put all of our features, we typically think of things in terms of features, and we put each of our features into that service or data all together, all kind of gummed up. Now, there are some advantages to doing it this way, and the big one is one single deploy. If you can be very good at deploying that one monolithic service or that one monolithic database, that's all you have to worry about. That's if you're very good at deploying it. And whenever it's still kind of small, you may be. But many times whenever you start getting into the tens, 20s, or hundreds of employees working out of the same code base, that can begin to get very difficult to manage. Your initial agility is super high because you don't have to worry so much about the long term because you're not really thinking about the long term. So your initial agility, because you can just throw any feature into it at any time, super high. You just throw it in there. And then lastly, from an advantage standpoint, if you do need to make broad changes, you can change whole swaths of the code all at once. Now, for me, I can also see this as a little bit of a disadvantage because while I can affect a large chunk of the code, that means I can break large chunks of the code, and I can break other people, the code that other people are trying to work on and are trying to maintain ownership of. The biggest challenge that I see with this design, more often than not, it all comes down to inconsistent state. So companies try to deal with this inconsistent state by putting in really crazy branching and merging strategies that sometimes work but usually do not. And it usually comes out in the form of things getting into production that shouldn't be there, whether that's bugs or features that weren't ready yet, because typically what happens is I've got feature A that really needs to go out. It's really important from a business perspective that it goes out. Feature C is halfway done, but it's not ready. And so we have to make a decision as a business to go ahead and throw that stuff out anyways, even though it's not ready. And it causes problems. It's difficult to get through the QA process, and it's difficult to get deployed out to our users, and that can cause us a lot of problems. So from a testing perspective, it's also very challenging to test a large monolithic application, because you can't just test what you build. You have to test the entire thing every time. There are companies that I've worked with who have testing processes that last as much as 60 days. 60 days from the day one, whenever testing starts, to whenever it gets done, for them to be able to deploy anything into production. That is crazy, and that is just a complete leech of time, happiness, and everything else that goes along with that, because it always feels like a death march trying to get that thing out into production. And then lastly, scalability, and not just scalability from a technical perspective, which of course that is important, because let's say I've built some new feature that's super awesome, and it's been well received in the industry, and so we start getting a ton of traction on it, and people are really excited about it, and then we need to scale it up. Well, we can't just scale it up. We have to scale everything up all at once, and that can be difficult. Whereas if you were just scaling out that individual component, any developer here could figure out how to meet the demands of a small component. It only becomes difficult whenever you have to manage that across the board for everything all at once, and how's the strategy that goes along with that. The other thing is scale from a resource perspective, from a personnel perspective. If we want to throw more engineers at our code base, if they're all going to the same code base, we reach a point of saturation where we start creating more slowdowns than we had before. And it feels like by throwing more bodies at it, we're going to get more work done. But in reality, we wind up creating more work for us to do internally. And it's just this weird cyclic cycle that happens. So that's where microservices come in. I really like this quote by Albert Einstein. I don't need to know everything. I just need to know where to find it when I need it. And so the difference between a monolith and a microservices approach, typically we try to put the service and data together. You don't have to do it that way, but that is typically how we do it. And then we want to break everything down by individual ownership domains. And each domain is going to go out with its data and its service together. And there's some distinct advantages to this. One, your long-term agility is super high. So once you get very good at microservices, things flow out into production pretty soon to after you hit commit on your code, and in a very safe and scalable way. Two, your testing becomes a ton faster. Now, people try to give me a gotcha at this point. People try to say, oh, I know, I got him. Testing, you still have to test everything, because if service A calls into service B, well, then you got to test both service A and service B if you're going to deploy service A. And that's just not true. And I'll give you a good example of why. Maybe this is something that you can relate to. So let's say you're using a third-party service like a SendGrid or a Twilio or something like that, right? Or Google Maps. So you wouldn't call Google whenever you're going out to QA with your product that's using Google Maps on the back end and say, Google, I've got some bad news. We're going to QA. We're going to need you to test all of Google Maps because we call into Google Maps, right? That just wouldn't make sense. It wouldn't make sense for you to do that. And for the same reason, it wouldn't make sense for you to do that with Google. It doesn't make sense to do that within your own organization whenever you're dealing with calling from one domain boundary into another domain. And then lastly, you get a ton of scale advantages, not just from a technical standpoint, but again, from a personnel standpoint. So let's say you start with a small team and you own all 4 of these domains, and then all of a sudden one of them takes off. Well, one, you can scale up the technology behind that one domain fairly easily. So if the data technology that you're using underlying it doesn't make sense anymore and you need to throw something more robust at it, you can change out how it handles its data without affecting anything else. Two, if all of a sudden the demands of these individual domains go up and we need to add on more domains and we need to scale up, we can then start breaking off ownership for various domains into new teams and create new domains and then start scaling ownership that way. And so it creates very clear boundaries for who owns what, and then that allows us to just scale up and out very reliably. But there are some challenges that go along with this, and the biggest challenge, more so than anything, is culture shift. Trying to adopt a microservices strategy within an organization has more to do with how you manage things from a business perspective more than a technology perspective. And that sounds counterintuitive at first, but in reality, you can't throw more technology at a company culture that isn't geared for high momentum, right? And so if you have a lot of red tape and you have a lot of cultural assets that are deeply tied to the way that you build from a monolithic perspective, that's going to be very difficult to change. And we're going to talk a little bit about that later and some strategies for how you can deal with that. Challenge number two, larger surface area. So instead of just dealing with one deployable unit, you've got all of these different domains that you have to deploy out. And that can be difficult, but I'm going to put the emphasis on the word can, because fortunately we live in an age where CI/CD is pretty robust and mature at this point, and we can automate the large majority of that process of getting things out the window, and that's huge, and we want to leverage that as much as possible. And then lastly, your initial agility is a little bit slower. You're going to take about a 10 to 15% hit whenever it comes to your performance and your how much speed you can get right at the beginning of creating a new domain. The payoff for that is that scoped domain, you're going to be able to add on to it really quickly in the future. So whenever you have new requirements down the line, you don't then have to test everything within your architecture and everything across the board on all of your services. You're just testing and deploying what you've built and nothing more. So isn't this just SOA? That's a great question. And in many ways, yes, this is kind of a child of SOA. This is kind of taking the lessons that people learn from SOA and drilling it down into something more meaningful. So some of the challenges whenever we dealt with traditional SOA were super rigid design patterns that weren't flexible to meet the demands of business, especially whenever it came to organizations that maybe were a polyglot organization that had some Java, some .NET, some Python, some Ruby, etc. Because of the rigid design aspects of SOA, that became very difficult to manage. In most deployments from a traditional SOA perspective, we introduced the concept of a monolith. So instead of having one big monolith in the back end, we would, through an ERP or an ESB, create a new monolithic piece of the system that could not scale independently and could not meet the demands of business. And this is generally referred to as a monolith. And then lastly, they tend to become a money pit. So a lot of organizations that were really big proponents of SOA would go in and want to map out every business process, everything that your business does. And these processes could take anywhere between 18, 24 months. And then by the time you're at the end of it, all of your processes have changed. And so you really got no value out of it. And then you buy, this big monolith that sits in the middle of it. And you spend a couple $1 million on that. It's just very expensive the whole way around. Microservices, on the other hand, super flexible designs. There's not really one right way to do it. The only right way is that things are fast and things can be automated and things move into production quickly. Other than that, there's not a lot of hard and fast rules. Two, no single point of failure, because we don't have that monolith. If an area of the system fails, it's easy to roll back the change to fix that part of the system. One, two, you'll still have some functionality within the system, even if individual components fail. And then lastly, at the end of the day, everything is just APIs. So whenever we're dealing with microservices, we really want them to be services, and we want to try and make them API focused as much as possible. So if you really must have an ERP, if you really must have an ESB, for whatever reason makes sense for your business, then you can still do that. Like, you've lost nothing from that perspective. So business domains, how do we think about the business in relation, how do we think about services in relation to the business? Because how we think about the technology as it happens with the business is super important for us as engineers and us as technologists. So the areas of the business, what exactly is a business domain? It's a part of the business that tends to use similar taxonomy or terminology to describe a business or technical need or value proposition. So what does that mean? Areas of the business that tend to use the same language, those are business domains. And you see these all over the place. Every company I've ever been to, whenever you open up a service or you open up a database, you're going to see either prefix or postfix common words, right? Some of those common words might be something like customers, right? So in your classes, you'll see customer underscore this, customer underscore that, or same in the database, customer underscore this, customer underscore that, customer addresses, customer records, customer chat history, customer, whatever. Same with invoice, invoice history, invoice items, invoice schedules, etc. And so we'll see kind of a repetitive nature of the names that we use within our individual field and within our company, kind of repeated over and over within the objects inside of our services and in our databases. But they're not just limited to business things. You can also see the same thing from a technical perspective. So we might have technical domains like logging, for instance, or perhaps authentication. Also authorization, because one is, who are you? The other is, what can you do, right? So all of those things break down into individual domains. But why would we do this? Why is it important? There's a couple of things it does for us. One, and probably the biggest thing it does for us, is it enables us to speak in a common language with the business. This helps us avoid miscommunication, right? So whenever we deal with business people and we deal with those around us who are making business decisions, we want them to be able to speak the same language that we do, and we want to be able to speak the same language that they do. By us doing that, we then as engineers get to be part of the ownership process for what comes into our own pipes. And us working along with the business more closely allows us to have a lot more rapid idea vetting, validation, and iteration. So we can spin on ideas super quick. Well, the reason for that is we as engineers tend to think about the long term. We're engineer minded, right? That's how we think about problem spaces. So when the business comes up to us and says, guys, we've got this great idea. We've spent 8 months talking about it. We've told no one, but good news, you're all going to have it done in 4 weeks. Well, that's super frustrating for us, right? We don't like that as engineers. Not only do we not like that just because it puts a lot of pressure on us, but a lot of times those decisions that are made in that way, we look at and we say, whoa, 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 we're already dealing with all of this memory pressure over on these sets of systems. We're already dealing with all of these database problems over on this section of the system. Doing this thing that you want, we're more than happy to do it. But doing the thing that you want right now at this critical juncture, we're going to cause failures. And those failures are going to hurt the business. And we don't want to hurt the business because that's where we work and we like this business, right? And so being able for us as engineers to be a part of that conversation and a part of those business decisions way earlier in the process helps the business and helps us as engineers, which ideally is what we want, right? That's what the business wants too at the end of the day. So how do we scale out teams? Because scaling your teams is just as important as scaling out the technology that supports your business. There is this notion within microservices, you'll hear it a lot from a lot of different articles and various topics on the subject, Conway's Law. Organizations that design systems are constrained to produce designs that are copies of the communication structures of those organizations. What does that mean? That means however you talk like a business, That is how you are going to design software. And it manifests in a very clear and concise way. So this is how this tends to look. We have a business team, they do business things. We have a UI team, they do UI things. They have a service team, they do service things, and a data team that does data things. But the problem with that is I, as a database engineer, I, as a database admin, do not care about your business decision. It's not what I get paid for, and it's not what I get dinged on, right? Whenever I think about how my bonuses are laid out for the end of the year, they're based off of the health and safety of my database, no more, no less, right? And so whenever you come to me with a business decision that I know for a fact is going to hurt my database, I'm not going to care about it because it's not my business, right? And that's super damaging to the business as a whole, because as opposed to coming to understandings and agreements, we tend to just throw things over the fence and say, well, you're going to have to go back to the business team. Well, you're going to have to go back to the service team. Well, it's not my problem. The data team won't sign off on it, so I don't know what to do at this point. It's their problem now. And then we just keep passing the buck, passing the buck, passing the buck. And that does not help our business at the end of the day. And we are, at the end of the day, all here to help the companies that we work for. So we can fix that by inversing that around and say, if we want to design software in a particular way, and we know that those software designs will be helpful to us as a business, let's change the way we communicate. Let's change the way that we do business fundamentally. And this is why that culture shift is so hard, because if you want to be super effective from a microservices standpoint, it starts with how you design your teams. And so how we design those teams tends to be, we have everybody involved. Everybody that can make a decision about whether or not we do a thing, they're all at the table, all at the same time, from the business, the UI, the services, down to the database, and everything in between. Because ultimately, if we can't come to a conclusion and decide that this is going to be good for us and us as a company and us as a technology group, it will not help us, right? And so we want to get as many of those people on board, and we want to be able to have them be able to make decisions quickly. And by breaking them off in this way, we're able to make more business decisions in parallel. We're able to make more technical decisions in parallel, and ultimately get much higher throughput on what we're trying to deliver to our customers, and build our companies out in a way that is going to make sense, right? So from an SOA perspective to microservices, when it comes to Conway's law specifically, SOA still tends to have a lot of, and monoliths, still tends to have a lot of siloing by role. And we've already seen how that can be problematic. Likewise, that tends to limit our total amount of scale from a resource perspective, because of the reason that we've talked about a few times now. And that's going to lower our productivity. And at the end of the day, we want high productivity. So for microservices, we're going to use highly cross-functional teams. We want everybody involved. We want to be able to make decisions quickly, and we want to not pass the buck. This is going to give us huge amounts of parallelism within our teams. We're going to be able to scale out our companies and our processes in a way that makes sense and can go to really any unbounded scale. And then lastly, that's going to give us huge productivity boosts as an organization, and even on our individual teams, not just from a company as a whole, but each individual team is going to perform better. And because we can have more of those high performing teams going in parallel, we as a company as a whole do much better. So how do we do this? Let's take this from the conceptual. What are some of the things we need to put this together? Usually we start with a gateway. So your gateway is your entry point into the system. Your gateway is where you start. Whenever we think about gateways, we put these in the constraint of individual sets of functionality, because our gateways just serve up that set of functionality, but do not necessarily house all functionality. And we'll get into that in a second. So there are two primary purposes for an API gateway. One, interoperability. Our end consumers should not care about what the underlying technology is, whether that's using Rabbit queues, whether that's using Kafka, whether that's using TCP or HTTP on the back end. It should not care, it should not know, it should not matter. And then lastly, we want to have distributed centralization. So we want to be able to have areas of functionality that we can go to via the gateways and have individual gateways for those sets of functionality. So that way we can still know as a whole what our systems can do and what we have the capability to do, but without pushing it all into the middle and creating middle lists like we had before. So our gateway tends to look like this from a architecture standpoint. Our clients come in through our load balancers, those load balancers then go to the gateways, and then we pass the requests along to our various services and combine in the gateway whatever data we need in order to fulfill some set of functionality. As a part of this, we'll also be doing protocol translation. So the gateway, so let's say our service A, for example, is using TCP with message-based encryption. So our gateway is going to be able to manage dealing with unencrypting that data and getting what they need from a TCP perspective, and then they're going to do whatever they need to from a security and authentication perspective, and push it all together along with whatever data is needed for the individual bit of functionality that the gateway is providing, and provide that back. So this also allows us to have some nice governance. One of the easiest ways to get governance out of this is to just put Swagger on your API gateways. And then each gateway has its own Swagger, and there are collectors out there where you can get all of your Swagger together in one big repository. That way you have one big area of exposure so that everybody in the business, from the business side all the way to the engineering side, knows exactly what sets of capability you have across the board, without you having to go out and actually specifically document it, which can be hugely helpful in an organization, especially as you scale out. So we've already talked about that three-tier architecture. Whenever we think about three-tier architecture, we have that presentation, business logic, and database. It tends to turn into this, and we're going to try to avoid that as much as possible. And the way that we do that is by having sets of services behind our gateway that our gateway calls into for individual sets of functionality. And then those services use whatever data stores that they need to. Typically what we want to do is we want to keep the schema of a data design separate from the actual implementation of that store. And that serves a couple of purposes for us. If you are an organization with one large enterprise database, you may have very good reasons why you can't ship individual databases with your services. And there are a lot of businesses that are very successful with microservices that don't. But many of them do, however, use schemas within those large enterprise databases to segment out that set of functionality. But the trick with that is, if you're going to segment things out by schema, never call cross schema at the database level, right? If you're calling cross schema, do that at the gateway level and combine across multiple services at the gateway level. Ideally, you're also not calling gateway to gateway, typically. So you've got your UI that sits on top of your gateway, and then your gateway that calls into a set of services. Your services call into whatever data store they need. Likewise, as in the case with our product service here, if we need to take one of those schemas later and then chart it off into some different type of data repository because it just makes sense for the problem that we're solving with that service, well, then we can do that, right? But we get to make the decisions as to whether or not that makes sense for our domain as a team, and we don't have to really care so much what all of the other teams are doing. Now, asterisks, again, there are sometimes some very good reasons why it might make sense for your individual use case to keep it all in one large enterprise database, especially if you're doing things like you're on-prem and you have high availability setups. And so going through that high availability exercise to add new databases wind up being a very challenging thing from an infrastructure standpoint. You might just still be all on the same enterprise database. But by being isolated by schema, if you have something that starts scaling far beyond the bounds of everything else and you need to get it off of that enterprise database because you've got one service that is effectively crashing all of the other services, and this is an incredibly common thing that happens, we want to be able to get it away from everything else quickly. We want to be able to isolate it so that even if it's running slow, it's not dragging everything else down with it. And so this, by isolating by schema in that way, even if we needed to use the same type of database, we can push that off into another segment. And basically the only thing that we have to do is incur a tiny bit of downtime to get a read back, slave setup over on that other setup, and then transition over. All of a sudden that becomes a write node, but just for that one data set. And so we can do some very nice things from that perspective. So where does UI fit into all this? We want to try to move away from rendered views. We want to think about UI a little bit differently in this paradigm. Remember, UI is just another consumer of services. That's it. Your UI should ideally go on its own cadence, because UI tends to be the slowest part of the process, because you get somebody from the business that wants just that right shade of mauve to go into the UI before it can possibly go out into production, or whatever the use case is. But really, at the end of the day, it's where your customers are interacting with the systems, so it tends to go slower because you want to make sure that those interactions are good. That said, a lot of functionality from a service perspective, we can get whipped out really quick, and we don't necessarily have to physically touch those services in order to make sure that they work. So we can automate those tests and just one-click deploy them right out to production. And if they pass all their automated tests, that service is good to go. I don't have to stand on formality. And as long as we're using good solid principles and keeping our services backwards compatible, we're not going to break anything out in production by pushing our backend services out. Worst case scenario, if we do, we roll back just that one small commit and that one change, and that helps us out. The other thing we want to do is try and favor simple UIs as much as possible. Simple HTML and JavaScript modules because we want to avoid baking in business logic. And that's one way that we can do that. That said, in a mobile world, we may have a mobile version of our UI. We may have multiple different ways of our UI. But keep in mind, UI is the most frequent thing to change within a business and the most frequent thing to get thrown away in a business. So we want to be a little bit diligent about the way that we think about UI. We want to think about it in terms of a mask. So if you think about a face, like my face, if I wanted to change my face, I could do it one of two ways. I could get plastic surgery, or I could put it on a mask. If I get plastic surgery, it's going to be kind of painful. It's going to be super expensive, and it's not going to look exactly like I wanted. Versus if I go buy a mask, I can radically, drastically change the way that I appear. But underneath, I'm still the same thing. And I can take that mask off at any time, and it's not very expensive, and then I can put on a different one, And so whenever we treat our UIs in this way, with our gateway serving up functionality for those UIs, that enables us to do things like, all of a sudden there's this new way of doing UI where desktop applications are now making a comeback, so now we got to go do this, or oh no, Flash is back, whatever it is, like the new version of Flash is back, and we have to rethink how we do UI completely. As those things happen, because if history has shown us anything, they will happen. We can be quick to market and quick to adopt whatever our customers are using to interface with services. So testing and deployment. Here's a couple of best practices that are going to make launching the most boring part of the cycle. We don't want exciting deployments. Exciting deployments are terrible. Whenever everybody has to get together and it's all hands on deck, and the management is excited because, oh no, we're going to production. We gotta, that's no fun, right? Nobody likes that. Nobody wants that. So how do we avoid that? There's a couple things that we want to keep in mind for testing. Automate everything. Automate testing, especially with the service layer, make it part of the CI/CD process, and then just automate that process all the way out to production. To keep the testing surface area limited to the domain that's being published. No more, no less. 3, isolate domain specific. Isolate an environment that is specific for integration testing, where you can put the data in a known state. So having the ability to drop a database in an integration environment and put it up in a known state with known use cases is super powerful for automating your service testing pipeline. It's one of the steps that a lot of companies miss, right? But if we're building our tests to constantly test for a set of fluctuating data, because we're not we don't have the ability to drop that data in an integration environment and put it up in a known state, we're not really writing good tests, and we're not really writing tests that will keep us from regressing long term. Some facts on containers. Containers are great for infrastructure, JavaScript, and Linux deploys, or Java, not JavaScript. Well, Node, but that's a whole different thing. .NET apps on Windows specifically benefit less from containers. .NET Classic apps are very homogeneous. And so a lot of what you gain by having containers is having a known system, because while I love Java, Java does tend to suffer from the fact of it's just 25 easy steps to get started, so long as you have the right JRE, so long as you have the right version of Linux, but only this one, because if you go to this one, it just won't work. You know, those little nuanced things. And that's totally okay, but that's where containers become super helpful, is to manage that. And as .NET Core comes out and more organizations are switching to Linux deployments for .NET, containers are becoming very useful for that as well. I'm a big fan of Alpine myself with .NET Core. I use it all the time, but it's not necessary, right? It's helpful, but not necessary. If you are going to use containers, make sure you have your storage. Make sure you know what your storage story is. So whether that's you're just using databases or whatever mechanism that you're using, but we want to make sure that our storage capacity has the ability to be durable and move around in case of failure. So we don't ever want what we're storing from a container standpoint to be isolated to the specific VM that it landed on. Your containers need to be able to move around, right? And so having our storage strategy figured out so that containers can die on one VM, pop up on another VM, and be back to the correct state is super important. So we've got another poll. What are you currently using for orchestration?
Okay, I'm launching it right now. It should be showing up on your screens. You have 4 choices: Kubernetes, Vanilla Docker, Service Fabric, or Other. Go ahead and make your selection. And also, just to remind the audience, we've gotten some really great questions in so far, but if you do have a question at any time during the presentation, go ahead and use your GoToWebinar control panel and submit your question. And hopefully we'll have a few minutes left. What do you think, Chase? You think we'll have, looking at the time right now, we're about 13 minutes to the top of the hour or so. Hopefully we'll have a few minutes.
Yeah, we'll have a few minutes. We don't got a lot to go through. So.
Okay, great. Well, I'm going to go ahead and close out the poll now then. Looks like just about everybody's voted who's going to vote. So looking at the results, the majority of folks love Kubernetes.
Awesome. Looks like the Kubernetes with other being the background. Yeah, awesome. Great.
Great. I'll go ahead and close these results. Let you get back to it.
So last, next we got health and monitoring. We want to keep our systems healthy after launch. How do we keep our services healthy? The easiest way to do that is leverage tools that are available like AppDynamics, Log4net, Application Insight, ElkSec, and of course, AppDynamics. And I say that I may be biased a little bit, I get that. But at the end of the day, I care more that you are using something to monitor. I'd love it to be AppDynamics, but please, if you're moving down into a microservice environment or any kind of complex infrastructure, have some way of knowing where everything is at. Ideally, whatever solution you're using, make sure it has a single pane of glass. So that way everything is all in one location and you can see end to end from where your customer comes into the system and how it goes through your various systems. All the way down to the database, you can track and know here's where we're having a problem. Remember, try to favor existing solutions. There are a ton of free and open source as well as paid for premium products available. Building out your own infrastructure around monitoring is incredibly costly and incredibly time consuming. So try to use what's out there because there is a ton of good stuff out there. That being said, what do you use? If you're using monitoring right now, what do you currently use?
Once again, we've got the poll up on the screen. You have 4 choices. ElkSec Zipkin, AppDynamics, or Application Insights. So go ahead and make your selection. And well, people are really voting for this one. This is great. Guys, also, I know we've gotten a couple questions in regarding the actual deck. When you receive the email post-event, you will be getting a link to the webinar on demand, and I believe that the slides will actually be included as part of that. So if not, I'm sure Chase would be more than happy to share them with you. And you can contact him offline, and he's got his contact information in the slide deck. So I'm going to go ahead and close the poll now, and we'll take a look at the results. Looks like AppDynamics, yay for you, right?
Excellent. That's what I like to hear.
Awesome. All right. Well, I'm going to go ahead and hide these results.
Awesome. So the last little point I want to talk about here is failure as a service. So how do we deal with mission critical failures before it ever happens? Now, this is not a starting point. This is like after you're well established in your journey down microservices. But we want to use tools like Keyhole has a thing called Troublemaker. There's Chaos Monkey. There's a ton of tools to randomly just stop applications in production, as well as Service Fabric has some built-in stuff. And the reason that we want to do that is if we know that during business working hours, our services are able to fail, we can go home at night and know that we're not going to get that call at 2 a.m. like, hey, I'm sorry for bothering you, but the system's down. We really need you to wake up and come in and spend all weekend here. Right? Nobody wants that call. So if we know that things are failing consistently during business hours, and we want that to happen during business hours, so that way, if there is a problem, we're there, we can fix it. So I wrote a thing called the Microservice Manifesto. It's got 6 pillars. You can find it at the microservicemanifesto.com or microservicemanifesto.com. First one is ownership. Without ownership, none of this will work. You want to enable ownership first and foremost before anything else within your business. 2, automation. Without automation, everything becomes very difficult if you want to try and move into a microservices environment. If you're having a hard time managing one application, imagine managing 100 of them if you're not very good at moving things out into production, or if it's a very manual process right now. 3, test everything. 4, make sure that people know where stuff is at. 5, make sure that once they know where it's at, that they can actually get to it in the language of their choice. This basically boils down to try to make sure you're using technologies like HTTP and JSON for public servicing of your microservices at the gateway level. And then 6, responsibility. Take ownership. And that goes back to first one. 1 is you have ownership. 6 is take responsibility for it. If they know that your other people are going to be consuming your services, and so be a good citizen from that perspective. Don't break existing contracts, and don't throw stuff over the fence, right? Just take responsibility for that which you own. A couple learnings from the field. 1, culture comes first. If you don't have a good system in place and a good culture in place that's going to really adopt this, you're not going to have a good time with microservices. Don't have company buy-in or the time to set up for success. Don't do microservices. Doing waterfall, don't do microservices. Be small, agile, as in nimble or sprightly. That doesn't necessarily mean pigs and chickens and ducks and weasels or whatever. Just be nimble, right? If you've got a small team and software is already going out really smoothly and awesomely, perhaps don't do microservices. If it's not going to add anything to what you're already doing, don't do it. Don't have CI/CD, don't do microservices. It will be super painful. You can use CI/CD tool as a pain gauge to gauge where you need to split. If you're having a really hard time moving a particular system through a CI/CD pipeline, if it's always getting caught up and you can't really seem to get it moved to production very easily because there's merge conflicts and we're constantly having a hard time testing it, that's a good indicator that maybe it's time to break that down a little bit. Only go as small as required for people not to step on each other, no smaller. I know it's got micro in the name, but that doesn't mean that you have to go to the nth degree on that. In fact, going too small can be just as painful as not going small enough. Test, and just in case you didn't pick it up, test. Automate everything. Everything possible, automate as much of it so that you can focus on delivering value, and you can focus on building what's important to you. Containers are helpful, but not required. Service Fabric and Kubernetes are helpful, but not required. No individual component, in fact, is a requirement at all. And data management, it does require a little bit of thought if you're going to go down that path of using schemas and things like that, but it's not necessarily hard, but it does require a little bit of thought. We want to try and separate our transactions away from BI. So whenever we're thinking about CRUD type operations, we want that to be a different set of operations from things like joining a bunch of complex data and trying to get something meaningful from it. So if we want all of the invoices for these sets of customers in this time frame that happen to purchase with these credit cards in this state, well, we're getting into BI type questions. We want to separate those services away from the services that do just CRUD type interactions. And then lastly, remember to breathe. It is just code at the end of the day, right? So we got about 5-6 minutes, and then I'm okay with staying a little bit longer, but that depends on DevOps.com and all that. But yeah.
Okay, great. Yes, as I said before, we do have some really great questions. So I don't think we're going to get to all of them, but if we don't, Chase has put his contact information on the screen there. So I'm sure he would be more than happy to follow up with you offline. You can just send him the message directly. Okay, first question: how do you do source code level analysis of microservices, and how they integrate with each other?
Great question. So the question is, how do you do source code analysis in a microservices environment? The best way to do that is leveraging tools like AppDynamics. So AppDynamics gives you the ability to see everything that's going on with all of your systems and drill right down to the line of code that's causing an issue, whether you're using Java, .NET, or other. So using products like AppDynamics are super helpful for managing those kinds of problems. Good question. Thank you.
Okay. Next question. Can you touch upon some strategies you have adopted to break down monolithic apps to microservices?
Yeah, absolutely. So there's a couple different strategies that I like to employ. The biggest one is using CI/CD as a kind of pain point. So if we see consistently that one system is having a very hard time with that, then the next question is, okay, is there a part of that system that is typically in conflict, that is typically where the errors are happening or where the merge stuff is happening? And then from there, if it's a very large application set, and a lot of people get very internally panicked whenever I say this, we want to start out by just duplicating the code, all of it, and creating two repositories of the same code, but one is going to be focused over the problem area, and then the other one's going to be focused over everything else. And so what that allows us to do is then over time, we can take that service that we're trying to isolate and start scooping all the other parts that aren't important to it away from that code, while at the same time in the other code base, start pulling it out. But those are two separate activities that can go in parallel. And that kind of gives us some good ways of managing that. One thing I would encourage is in a lot of, especially if it's old code that's been around 5, 10, 20 years, there's a lot of good stuff in there. Don't throw away the baby with the bathwater. It may be ugly, but if it's ugly and runs well, then it doesn't matter if it's ugly. That said, we all do want beautiful, great looking code, but it's okay, especially whenever you're not building greenfield, if it looks a little haggard.
Okay. All right, great. We are about 1 minute to the top of the hour, so unfortunately we're not going to be able to get to any more questions, but I do want to thank everybody who did submit a question. And as I said earlier, Chase's email is right there on the screen, so feel free to follow up with him directly regarding any questions that you do have. Also want to remind the audience that today's event has been recorded, so if you missed any or all of it, you will be receiving an email that contains a link to the webinar on demand. You'll also be getting a copy of the slides, excuse me, for download. The webinar is also going to be on the devops.com website. So if you want to check the website there for it, it's just under the webinars tab on demand. And while you're there, take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Chase O'Quine, thank you so much for such a great presentation. Judging from the questions we got in, I know the audience got a lot out of it, and I did too. So thanks so much. I appreciate it.
And thank you.
Great, great. Well, this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.